Very good morning, friends. Today we are going to discuss about the protection of amines and amino acids. These are generally protected as carbamates. Various varieties of carbamates are prepared, and one of the widely used versatile method of protecting the amines and amino group in amino acids is preparation of tertiary butyl carbamates. They're called as Bach protection. What is this Bach stands for? Amines, the nitrogen has lone pair of electrons, reacts with tertiary butyl oxycarbonyl chloride. The carbonyl carbon being the electron deficient carbon, as they are flanked between two electron withdrawing groups chlorine and oxygen. It is sufficiently positive enough to receive the electrons, and nitrogen lone pair of electrons are sufficiently nucleophilic enough to share that electrons, and the lone pair of our electrons are shared with the carbonyl carbon, and as it has to maintain its tetravalency for its stability, it removes the chlorine as it's a very easy leaving group. The H plus from the amino and Cl minus from the carbonyl chloride combines together to leave as HCl, and a amide bond is found between the carbonyl and the amine to give carbamides. The same reaction can be accomplished not only by using tertiary butyloxy carbonyl chloride but also by using butyloxy carbonic anhydride in the presence of a base like sodium hydroxide and reaction be carried out in water. This will be useful for those amines and amino acids which are miscible with water, and those which are not miscible with water we use methanol or DMF under the basic conditions by using triethylamine or diisopropylethylamine and so on, and treating with butyloxy carbonic anhydride. The same reaction can be accomplished by using tertiary butyloxy carbazide in the presence of an aprotic solvent like DMSO. When they are not soluble in the polar solvents, the few amines and amino acids, we go for aprotic solvents. This is the various methods of preparation of tertiary butyl carbamates. These tertiary butyl carbamates are easy to cleave, and at the same time they are also stable under the reaction conditions. That's why they are the ideal way of protecting the amines and amino group in amino acids. The cleavage of tertiary butyl carbamates and liberation of amines can be accomplished by treating with a mild or dilute HCl in the presence of ethyl acetate, or we can also use strong acids like trifluoroacetic acid, thiophenol, and DCM. The cleavage is accomplished by using acid chloride and methanol. We can also carry out the deep protection by using an oxidizing agent like ceric ammonium nitrate in acetonitrile. These versatile methods of cleaving the carbamates. They can also be protected by preparation of allyl carbamates. In other words, in the form of allyl carbamates. I take amine and treat with allyloxy carbonyl chloride, and I'll get correspondingly allyl carbamate, which is represented as alloc. The lone pair of electrons on the nitrogen attack on the carbonyl carbon, and the chloride ion gets kicked off in the form of HCl, and it gives rise to corresponding allyl carbamate. The same reaction can be carried out by using allyloxy carbonic anhydride in place of allyloxy carbonyl chloride. When I use allyloxy carbonyl chloride, HCl is released, and that HCl which is released should be neutralized. That's why I use pyridine, which I represent it as PY. When I use allyloxy carbonic anhydride, I use DCM as the solvent. The allyl carbamates formed can be reductively cleaved by using triphenyl phosphine palladium, tetra triphenyl phosphine palladium, along with TBTH. TBTH stands for tributyltin hydride in the presence of acetic acid. The same allyl carbamate can be cleaved by using tetratriphenyl phosphine palladium. Instead of TBTH, we use dimedone and THF as a solvent. They can also be protected by formation of benzyl carbamate, which is represented as CBZ or Z. The amine or amino acids are treated with benzyl oxycarbonyl chloride. The carbonyl carbon is electron deficient. That's why the lone pair of electrons on the nitrogen can be shared with the carbonyl carbon, and the chloride ion gets kicked off, and they combine to with HCl and loses as hydrogen chloride. I'll get corresponding benzyl carbonate. This reaction can now be carried out not only by using benzyl oxycarbonyl chloride in the presence of a mild base like sodium carbonate. This can also be accomplished by using other reagent benzyl oxycarbonic anhydride in dioxane water. They can be reductively cleaved by using hydrogen in the presence of palladium carbon, hydrogen in the presence of palladium carbon, and ammonia in the presence palladium carbon in the presence of ammonia. They can be cleaved by using ammonium formate in the presence of tribromoborane. They can also be cleaved by using the base like potassium hydroxide in the presence of DCM and methanol. Here, the fourth method of protection of the protecting of amine group is by using 9-fluoromethyl carbonyl chloride. It is called as FMOC protection. The amine or amino acid can be treated with fluorinyl methyloxy carbonyl chloride, carbonyl chloride bearing the electron deficient carbon. The lone pair of electrons are shared with it, and Cl in the easy leaving group leave as HCl, and we get fluorinyl methyl carbamate. This is generally called as FMOC protection. Not only by using fluorinyl methoxy carbonyl chloride in the basic condition in aqueous dioxane, the carbamates in the form of 9-fluoronyl methyl carbamate can be accomplished by using FMOC OC6H5 in the basic condition using the acetone. We can cleave by using amine bases, mild bases like piperidine, morpholine, diisopropyl ethylamine, TBAF, and DMAF. The fifth method is protecting the amino group by using 2,2,2 trichloroethyloxy carbonyl chloride to form 2,2,2 trichloroethyl carbamate. We call it as drop protection. Amines reacts with trichloroethyl oxycarbonyl chloride. The amino group, lone pair of electrons which they shared with carbonyl carbon and chlorine leaves as HCl, and that can be neutralized in the presence of a base to give rise to TROC. They can be formed by using trichloroethyloxy carbonyl chloride in the presence of base like pyridine or aqueous sodium hydroxide. They can be cleaved by reductive cleavage method by using zinc, tetrahydrofuran and water as solvent, maintaining the pH at 4.2, and can be cleaved by using zinc lead couple and 4 is to 1 ratio of tetrahydrofuran and 1 molar ammonium acetate. Overall, there are 5 methods of protecting the amino group and amino in the amino acids. Let us summarize the whole thing. They are protected basically as tertiary butyl carbamates, which can be accomplished by using protecting reagents like tertiary butyl carbonyl chloride in the presence of a base, or by using tertiary butyloxy carbonic anhydride in the presence of a base, or by using tertiary butyloxy carbazide in the presence of an aprotic solvent like DMSO. These tertiary butyl carbamates which are formed have striking features like they are having very good stability under high temperatures, and also they are stable under basic condition when we use nucleophilic reagents also. They are highly reactive towards intramolecular nucleophiles and also electrophiles. They can be deprotected by using 3 molar HCl or by strong acids like trifluoroacetic acid, and can also be deprotected by using oxidizing agents like ferric ammonium nitrate. Another method of protecting the amines is in the form of allyl carbamate, which is accomplished by using the protecting reagents like allyl oxy carbonyl chloride or allyl oxy carbonic anhydride. This allyl group can act as a reactive site for many transition metal mediated reactions like palladium or ruthenium catalyst. They are stable towards acidic or basic conditions in the mild form. These allyl carbamates which are formed can be deprotected by using the special reagent prepared for this by reductive method by using tetra triphenyl phosphine palladium in the presence of TbATH or dimidone. Benzyl carbamates protection which is given as CBZ. This can be accomplished by using protective reagents like benzyloxy carbonyl chloride or benzyloxy carbonic anhydride, which we have represented here. These benzyl carbamates have two crystal forms, alpha and beta, and alpha is found to be more stable under normal conditions. They are deprotected by using the reductive method by using hydrogen and palladium carbon, ammonia and palladium carbon. Can also be deprotected by using ammonium formate and by using a base like potassium hydroxide. They are protected as FMOC 9-fluorenyl methyl carbamate, which is accomplished by using protecting reagents like FMOC chloride or phenyl methyl oxycarbonyl chloride under basic condition, or by using FMOC O6 F5 under basic condition again. The FMOC protected amines or amino acids beauty lies in its rapid and selective cleavage by using weak and moderate bases, whereas Bob protection require little stronger bases. Here, the deprotecting agents used are mild amine bases like piperidine, morpholin, diisopropyl ethylamine, TBAF, and DMA. This method of protection of amines in amino acids, as FMOC protection as it is represented, is very much useful in solid phase peptide synthesis. They are highly stable towards acidic condition, and as this 9-fluoromethylene group has tendency of strong absorbance of UV light, they can be deprotected by using the UV rays also in the automated solid phase peptide synthesis. Another method of protection of amines and amino acid is in the form of TROC, which can be achieved by using protecting reagents like trichloroethyloxycarbonyl chloride in the presence of a base. The beauty of this TROC is that the protecting groups like amines can be protected, and also it can be used for protection of alcohols and phenols. They are more versatile than that of other protecting groups. These drug can be used in conjugation with bases like pyridine or the sodium carbonate in the presence of DCM and HTHF. They are reductively cleaved by using deprotecting agents like zinc in THF and water, or using zinc and lead couple. This is all about the various methods of protection of amines or amines in the amino acids. Next presentation, let us deal with other concepts. Till then, have a nice day. Thank you.